Welcome back everyone. So in today's session we are going to see exercise 1.4 of real numbers. In this exercise we have to check without actually performing the long division. We have to say whether the following rational numbers will have a terminating decimal expansion or a non-terminating decimal expansion. So without actual division you can see there are 10 different fractions given here in the first question. Now looking at this fraction you have to say whether it has terminating or non-terminating repeating, because you know that few fractions terminates, few fractions do not terminate, they are non-terminating. Like example, if I take the fraction 1 by 5, okay, so this terminates because 5, if I divide 1 by 5, then 0 point, I can take 0 and I can take 5 2 times is 10, okay, the remainder is 0. So 1 by 5 is 0.2 and this is terminating decimal. Okay, we have learned about three different types of decimals. One is terminating decimal, then another, if I take example of 1 by 3, 1 by 3 when you divide, what happens? 1 by 3, 0 point, what happens here? 3 times is 9, yeah, then again you get 1, then you take 0, 3 times is 9, 1 0, this continues. So 1 by 3 can be written as 0.3333, or you can write 0.3 bar also. So these are the two types of decimals. One is terminating, another is non-terminating repeating decimals. So these two types of decimals come under rational numbers family, which we have already discussed in the introduction. Now there is another type of decimal. What is that? Another type of decimal is non-terminating non-repeating. So non-terminating non-repeating decimals are irrational numbers. We will not go in that. Okay, so these all are the fractions. So either the answer of this has to be terminating or non-terminating repeating decimal. So we are going to check that without actual division. This is very important concept for 1 mark. Okay, MCQs. This can be asked in MCQs. You can solve it very quickly if you know the concept, if you know the method of solving without actual division. If you divide it, then it takes a lot of time. Okay, so let's have a look at this now. For doing these questions you must remember these two rules. Okay, very simple rules. First rule is, if let x is equals to p by q be a rational number such that the prime factorization of q is of the form 2 power n 5 power m, where n, m and are non-negative integers, then we say that x has a terminating decimal. X terminates. Okay, very simple. If I explain you this in simple words, okay, let me explain you 2 bits from this question number 1. So the rule is, if the denominator, okay, in p by q, if p by q is a fraction, if you can write q as prime factors of 2 and 5s, okay, if the denominator has the prime factors as 2 and 5 only, that is 2 power n 5 power m, I can say n and m can be any power. Okay, so if the denominator of any fraction can be written as 2 power n 5 power m, or only 2's in denominator, okay, we can have both 2 and 5, or we have only 2's or only 5's in denominator, then we can say that this has terminating decimal. This is terminating decimal. if this cannot be written, if q cannot be written in this form, okay, if q cannot be written in the form of 2s and 5s, or only 2s or only 5s, like if q has the prime factorization, like if you have 2 as well as 5, but you have another number with it like 17, so this is non-terminating repeating decimal, non-terminating repeating decimal. So if you make it simple, you should have only 2s and 5s, 2 or 5 or 2 and 5 both. What if this denominator can be written as a prime factors of 2s or only 5s or both 2 and 5, then we can say that it has terminating decimal expansion. If it has any other number other than 2 and 5, like it's 17 or you can take 11, it can be any number, okay, 13, then we say that it has non-terminating repeating decimal. This is the rule for checking whether they have terminating or non-terminating repeating decimals. So let's begin with the first bit. In the first bit, p by q is terminating, so the rules are p and q must be co-prime. I said you what are co-primes. Co-primes means they should not have common factor other than 1, means they should be in simplified form. 13 by 3125 are not further divisible, so their common factor is 1, and q should be of the form 2 power n 5 power m. So let's check it now. This denominator 3125 will find the prime factors very quickly. 3125, the prime factors are 5 times, so that is 5 power 5. Okay. So I can directly say here that as this 3125 is written in the form of 5 power something, that is 5 power 5, I can say this is terminating decimal expansion, okay, because there is 5 in it. And if I want to write 2, I can write 2 power 0, 5 power 5 also, that doesn't matter, okay. So it is exactly in the form of 2 power n 5 power m, the definition which we discussed. So next let's take a look at the second one, 17 by 8. So 8 can be written, okay, these are the same things, okay. You have to check whether it is co-prime or not, means it should be in simplified form, the fraction should be in simplified form, and it is simplified form only. 17 by 8 is not further divisible by any number, isn't it? So p and q are co-prime, yes, 17 and 8 are co-prime, so you can proceed. Now we have to check whether this 8 can be written in the form of 2 power n 5 power m. So 8 prime factors of 8 are 2 cube. So I can say yes, this is also terminating, because I said you if the denominator has only 2s or only 5s as the prime factors, then they are terminating, okay. So 2 cube and 5, 1 into 2 cube I can write, and I can write 5 if I want, okay. So I can say this is in the form of 2 power n 5 power m, and it is terminating decimal expansion. So when this is asked for MCQs, you should not do all these things, okay. You should not do these all things or these all things. You should quickly find the prime factors, and it is 2 cube, so you can directly say yes, it is terminating decimal, that's all. And mostly this will be asked in 1 mark question only. Hope it's clear to you all. Let's have a look at another example. We'll take another question like fourth one, we will see fifth one, third one, all you have to do in the same way. Let's take the example of fourth one, 15 by 1600, but you can see 15 by 1600 are not co-primes here, so we will divide them by 5 table, okay. 5 3 times and 5 3s are 5 2s are then 0, 3 by 320, So when a number is not in simplified form, first write it in simplified form. That is the first rule. Okay, P and Q are co-prime, so by 320. So 3 by 320 is the simplified form of 15 by 1600. Now I'll check whether 320 can be written as powers of 2's and 5's. So you can have a look here. I prime factorize 320, so I got 2 power 6 and 5 ones. So 2 power 6 into 5, I can say it has both 2's and 5's. So this is also terminating decimal expansion. It is in the form of 2 power n, 5 power m. What is n in this? 6, and m is 1. So I am again saying you, these all things are not required if this question is asked in 1 mark. What is required? Just you should simplify this. The denominator you should prime factorize and see what are its prime factors. If they have 2's and 5's, or only 2's or only 5's. Okay, there are 3 cases. Like in the first one we had only 5's, this was terminating. In the second one we had only 2's, so that was also terminating. Okay, and in the fourth one we have both, you can see 2's and 5's, so this is also terminating. Now these 3 are terminating. If you have a look at the third bit, you can see 64 by 455, they are co-prime already. So if I prime factorize the denominator, that is 455, I am getting 5 into 7 into 13. So what do you say about this? Does it have only 2's, 5's, or it has any other numbers? Yes, it has 7 and 13 extra. So I can say that it is non-terminating repeating decimal expansion because it has other number other than 5 and 2's. Clear? So the denominator is not in the form of 2 power n, 5 power m. So this is the basic rule for doing this problem. Okay, if the denominator has other numbers other than 2's and 5's, like here 7 and 13, then you can say that is non-terminating repeating decimal expansion. Clear? So following this rule, you can try all the other bits for your reference. I have given all the bits here. Like the fifth one, you can see the denominator is prime factorized and we are getting 7 cube, so it is non-terminating repeating because we need 2's and 5's only. It has 7. Then the 8th, 6th one, all the bits I have done here for you. So you can complete this question number 1 in your classworks, and make sure you all complete this and submit your classworks because this is the end of the chapter. Okay, the second question of this exercise says whichever are terminating decimals, you have to find what is the answer for it, decimal expansion for it. So for that you can just normal division you can do and you can get your answer. Okay, thank you.